Airborne particle contamination causes defects during semiconductor fabrication. Even particles as small as 10 nanometers, called nanoparticles, can negatively impact yield. Surprisingly, these tiny particles are not routinely monitored in critical environments. Many manufacturing facilities use optical particle counters, or OPCs, to detect airborne particle contamination. However, even highly sensitive OPC instruments do not have the ability to detect nanoparticles. Why is this? First, nanoparticles are too small for optical detection. Second, nanoparticles can exist in the absence of larger particles. Therefore, larger particles are not an indirect measure of nanoparticles. The only instrument suitable for monitoring airborne nanoparticles is a condensation particle counter, or CPC. This short demonstration will highlight why CPC technology is critical to safeguard manufacturing environments against nanoparticle contamination. Let's get started. Since combustion is an excellent source of nanoparticles, we'll use a candle to generate high concentrations of particles in the 10 to 100 nanometer size range. Then, we'll compare particle measurements using a CPC versus a high-sensitivity OPC. Nanoparticles generated by the burning candle will enter the airflow through a small hole in the HEPA filter. This filter dilutes the particles to a concentration that will not harm the instruments. The diluted airflow is split and sampled simultaneously by the two particle counters. On the left, TSI's AeroTrack Model 9110, a high-sensitivity 0.1 micron optical particle counter. On the right, TSI's AeroTrack Model 9001 Cleanroom CPC, with the capability to measure nanoparticles down to 10 nanometers. Both instruments will record 1-second samples and report particle concentration in particles per cubic foot. The results are shown in cumulative size mode. Therefore, the concentration at the smallest size represents the total particle concentration for each sample. When sampling room air, both instruments detect significant particle concentrations. As expected, the CPC detects more particles than the OPC. Now the candle is lit and placed near the small hole in the filter. This allows particles to enter the airflow. The CPC immediately indicates a 30-fold increase in total particle concentration. At the same time, the 0.1 micron OPC does not detect any increase in total particle concentration. It's clear to see that nanoparticles are generated in the absence of larger particles, and that a CPC is absolutely required to detect them. Now the candle is blown out, and the OPC detects an increase in total particles. These are large particles associated with visible soot and smoke. After a short time, both instruments return to baseline. When the data is graphed, differences between the two instruments are even more apparent. After the candle was lit, nanoparticles were immediately detected by the 10 nanometer CPC. No increase in total particles was detected by the 0.1 micron OPC. When the candle was extinguished, larger soot particles were detected by the OPC as expected. Within minutes, both instruments returned to baseline. This simple demonstration confirms nanoparticles can exist in the absence of larger particles, and that only a CPC can detect a spike in nanoparticles. Don't let undetected nanoparticles impact your manufacturing process. Trust TSI's AeroTrack Cleanroom CPC to safeguard many environments, process gases, and critical tools against costly nanoparticle contamination.